So LineSmarts now has what we're calling a locations feature, and that's essentially a plan view, and it lets you do a number of different things. And this video is to demonstrate what you can do and provide a few examples. So for the first example, if we click on this measurement here, what you can see is that it's a span measurement that's been created. And if we select from the drop-down menu here, we can go to location. And what you can see is an aerial image with 3 points defined on them. Now, if we select this image, and then we select these 3 points, the yellow one is the observer, the red one is the left pole, and the right one is the blue pole. And this is just a Google image, and you can do all the sort of things that you'd expect to be able to do with a Google image. Zoom in, zoom out, and so on. So if we go back, then the other thing that we'll see about this is down below here we've got the span heading, and then the coordinates for the left support, the right support, and the yellow observer. Now if we go back and we look at the next example here down below, and again we've got a span that's been defined. So, and this of course you've identified the poles in the image and the distances to them. Now if we go to the location, what you can see here is the points that have automatically been created are not spot on to where the poles are in the image. So if I select on this image, you can zoom in here, you can see the shadow from the pole here. In fact, you can actually see the line. And that blue point should be on there. But because this has been captured with a phone and potentially it hadn't had time to acquire the satellites, it's not exact. So what we can do with this is we can hold on this yellow, the observer icon, and move this. In fact, I'll go a bit closer until the pole's in the right place. Then we can zoom out. But what we see here is, having done that, the red one's still not exactly in the right place. So what's happened here is that the compass on the device hasn't been precisely calibrated either. Actually, this is reasonably good. This is probably about as good as you'd expect the compass to get. However, we can adjust for this using these circular arrows. So once we click on that, we can then move this yellow line. And that's rotated the observer's orientation around until the poles are in the right place. And potentially it could be that you need to adjust the rotation and then adjust the position of the observer as well, incrementally to get them in the right place. But this is pretty good. Now if we go back, so this, if you've got the range and the position of the structures in your image, that's something that's fairly easy to do. The next thing we can do, in this example here, I haven't yet been able to capture the range of the right support. In fact, the laser rangefinder that I had was unable to get the distance to the furthest pole. So what we can do in this case here is, first of all, if we go in and we can identify the position of this pole, and in fact, I should also go in and get the position of this right pole here. So we've got that. And then what we can do is go into location. And the first thing I'll do is I'll adjust for the position of the observer. Now it's a bit hard to see in this image, but when I took this, I believe I was standing around about approximately there. And if we go out, and what we can see from this is the red one there, the red needs to rotate to about there, and that pole is now spot on. And now we just need to see we can see the blue line there, and there's the pole. So what we need to do is add the right hand pole. So we can do that just by clicking there, and having done that, if we go back and to the span, that has now calculated the span length for us. Now that's not quite as precise as doing it using the laser rangefinders, but in this instance where I was unable to acquire the distance using a laser rangefinder, this is a way that I've been able to get that span, and having specified that span, I can do all sorts of other measurements, the ground clearances and the wire tensions and so forth. Now looking at another example that we've got here, in this case I didn't have a laser rangefinder with me. So again, what I can do is just go in and I can identify this left pole, do the same for the right pole, and go back. And now if I go to location, what I can do is adjust this location here, I've got to click onto it, hold on to that, and now what we can see is it's showing us these lines. Now here it's actually we can see that the blue line and the red line are intersecting already with the base of these two poles. You can see the shadow there and the shadow there. So in actual fact the compass is perfectly oriented in this case. So yes, I've moved the observer to the position where I was standing. And now if I just click on this plus button, and I can that was the red pole. I'll get the blue pole in position. Right. So now this pole here is in the wrong place. I've put it in the wrong place. So if I move that down there, and that will be just following the red line. So I just need to hold that down. And it will automatically stick to the red line. Now I can click on this and add the blue one. Again, I've not quite put that in the right place, but if I move that, so I can move this blue one anywhere, and it'll always snap back to the actual line. So that's now in the right place, and the red one's in the right place. And so if we go back to span info, and it's now measured a span between those two poles. Now for our final example, going back to this one here. So in other words, you can go out even without a laser rangefinder. All you need to do is remember where you're standing when you took the image, and be able to see that in the aerial image, and also to be able to see the poles in the aerial image. And you can measure the span and all the other things like tension and so on. Now the final example I was going to show, in this case here I've not measured the distance to the span. I don't have those distances, and in fact in this image I can only see the tower in the distance. So if I identify that in the image, and now I can go to the location. Now in this case here, I click on here and I want to move the observer to where the end of this fence is. That's where I was standing. And so what we can see here is the blue line should intersect with that tower. So I can rotate that. And And so first things first, I'm going to add this tower, which isn't in view when we're looking at the image. Then I can hit that plus again, and I can add it at this right-hand tower. And now if we go back, we can see that we've got the points for the left and the right-hand structures. Oops. And if we look in here, we can see that we've measured the span. So you can see that the distance to the left support is shown in blue italics. That means it's been calculated off the actual plan view. And we can see that the span there is 470 meters. Now what we can do with this, having done that, is we can do these other sorts of measurements. So just as an example, I'll measure a conductor tension. So let's say that it's, in this case, it's nitrogen. And I'll click on this image, and I'll get in here, and I'll just measure this conductor here, roughly. So we'll get a center point here. And we'll go as far as we can really see what this will do. So that's calculating for us the tension of that wire without even being able to see the initial structure. In fact, you could even do this, albeit potentially a bit less accurately, if you could see neither of the two structures, just by knowing where the observer was in the plan view in the two structures. So that is the new location tool that we've added. And I guess what it means is it just gives you a bit more freedom, especially for those transmission lines where it can sometimes be difficult getting both structures into the image, or where the distances are that far that it can be hard to get them with the laser rangefinder. But of course, it is always better to use a laser rangefinder. You get more accurate results, but in a lot of cases, it's still pretty accurate even without using them.